In this video, we're going to look at an example using the ratio test. So we're being asked to determine whether the series from 0 to infinity of negative 3 raised to the nth power over 2n plus 1 factorial is absolutely convergent, conditionally convergent, or divergent. So, the big clue here that tells us that we probably should use the ratio test is the fact that I've got a factorial in my terms of my series. Factorials have lots of cancellation if you use the ratio test. So that's usually a good hint that we want to use the ratio test in order to solve the problem. Remember, ratio test gives you one of two conclusions. It either gives you that the series diverges or that the series is absolutely convergent. We don't have to worry about conditional convergence if the ratio test actually applies. All right, so let's go through the steps. Remember, the ratio test is we look at the limit of the absolute value of the ratio of consecutive terms, a sub n plus 1 divided by a sub n. So the numerator here is just the terms of our original series, except that we've taken out n and we've put in n plus 1. All right, so first thing I did here was just simplify what's inside the parentheses of the factorial. So you get negative 3 to the n plus 1 over 2n plus 3 factorial, and then divided by negative 3 to the n over 2n plus 1 factorial. Let's put the pieces together that match. Put the negative 3 to the n plus 1 over the negative 3 to the n, and put the 2n plus 1 factorial over the 2n plus 3 factorial. Now let's simplify. Here, the exponent on top is 1 bigger than the exponent on bottom, so that fraction just simplifies to negative 3. On the second fraction, 2n plus 3 is bigger than 2n plus 1. So there are more factors in 2n plus 3 factorial than there are in the 2n plus 1 factorial. So let's rewrite 2n plus 3 factorial until I see the 2n plus 1 factorial will cancel. First term is 2n plus 3, decreased by 1. Next term is 2n plus 2, decreased by 1. The next term will be 2n plus 1, and now my factorials match. So 2n plus 3 factorial can be rewritten as 2n plus 3 times 2n plus 2 times 2n plus 1 factorial, and now those 2n plus 1 factorials will cancel each other out. Last thing we notice is we have absolute value bars around everything. The only thing that's going to do for us is knock out this negative sign. So when we rewrite everything, we'll have 3 on top, that's it, over 2n plus 3 times 2n plus 2. And certainly as n gets large, this fraction goes to 0. Since the limit we got, 0, is less than 1, the ratio says that we conclude that the original series is absolutely convergent.